All right, so this is section 5 of chapter 6 for geometry, and we're going to talk about inequality theorems for two triangles. So if I have two triangles, right? So this triangle and that triangle, right? And I assume that these sides are the same length. These two sides are the same length, but angle number 1 is smaller than angle number 2, or vice versa. Angle number 2 is bigger than angle number 1. I should be able to induce from this side angle side inequality theorem that side opposite of the larger angle, so again, angle 2 is, greater than angle 1 that's given to me, then that side opposite angle 2, which could be side A here, has to be bigger than side B opposite of angle 1. So these are two different triangles that aside from, right, I have an aside and aside. If I had that angle included, 1 and 2, if they were congruent, then A and B would be the same. But if 2 is a little bit bigger than 1, then A has to be a little bit bigger than B. That's what we're trying to figure out. So A ultimately is bigger than B, and that's apparent. And I can use this side angle side inequality theorem. So after I prove what I want to prove, sometimes you have to say side angle side inequality theorem, right? Might just assume the theorem, but THM wouldn't hurt me to write. So side, 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 same thing, just the other direction, right? I have the exact same two triangles. I don't even have to draw those again. Just look above, right? If I first told you that A was bigger than B, then you definitely could assume that angle 2 is bigger than angle 1, but this time it would be side, side, side inequality, right? Because if A and B were congruent, then angle 1 and 2 would be congruent. But since angle A is a little bit bigger, or excuse me, not angle A, since side A is a little bit bigger than side B, then angle 2 has to be a little bit bigger than angle 1. Right, so this is side, side, side inequality theorem. So I have some models to show you in class if that's not really making sense. But otherwise, that's how this works. You just jump into some examples, right? What can you deduce? What theorem supports your answer? So if I'm looking at this first triangle here, I'm given this side 15 and 16, right? And 16 is clearly bigger than 15. So this angle opposite of that 16, angle A, would have to be bigger than angle D. That's all I'm going to say for my what can I deduce. Angle A is bigger than angle D. And since I had sides first, this is going to be side, side, side inequality, right? So sometimes write that theorem, you don't really have to. On the next two triangles, I'm given angles in there, right? And this angle, 41, whoops, I meant to change color, didn't quite work out. 41 is bigger than 40. So that means that this side, YZ, has to be bigger than VW, right? So I'm focusing on angles first, looking at the side second. Side VW is going to be smaller than YZ, right? Since I had a side angle side kind of going on, but one of my angles is a little bit bigger than the other, I can conclude this, and this is a side angle side inequality theorem situation. So then if I look at this next one down here, I have to infer some things. Remember, you always have those reflexive sides. So I actually do know, excuse me, two sides of each triangle are congruent. And the included sides, this 87, right? This 87 is going to be a little bit smaller than the 93 that would complete my 180 there. So that means that I know that this side BC is bigger than side AB. And again, since I had angles first, this is going to be side angle side inequality. Right? This other one, kind of the same thing. I just pick out the bigger angle. 91's bigger than 90. So that means that in this situation, RQ would have to be bigger than LN, and it's going to be my side angle side inequality. Again, anytime you want to pause to practice, if you want to see if you can figure the next one out first, go for it. But when I'm looking at this next one here, I have to remember again to use my reflexive side here. So I have that side and I have the 10s that are congruent, right? So what I'm really worried about are angles 1 and 2 and or these sides 5 and 6. So I'm going to look at 6 bigger than 5, right? So again, big opposite big, small opposite small. Angle 1 obviously has to be bigger than angle 2. So same things we've been doing, essentially, just a different way of thinking about it, right? So this is going to be my side inequality because I had sides first. I looked at the 6 first, and then I figured out 1 would be bigger, right? This next one over here, I have all these 17s that are congruent to each other. So I just want to look across the board. These sides are congruent. These sides are congruent. It's the sides opposite again. 8.5 is just a little bit bigger than 8.3. So that means that my angle opposite at 8.5 is going to be a little bit bigger than the angle opposite at 8.3. So I know in this situation that angle 2, just got a little goofy there, angle 2 is bigger than angle 1, and this again, sides first, is a side inequality. So again, sometimes some visuals help. I'll let you see that in class, but hopefully you catch on to the idea pretty easily.